Good morning, class. Right now for me, it's the Thursday at 5:54 a.m. I think some of you have been affected by the power outages. I hope you are staying safe, but we're going to go over the lesson for today through the video. I will introduce a couple geometric properties that you probably have seen before, just simple ones that you most likely saw in middle school. We're going to review those, and then we're going to do two more practice of flow charts. I'm planning to have another video there. You will be able to see a video of me explaining some of the flow chart in the triangle congruence worksheet. Okay. So the first thing is I'm going to ask you to copy this diagram. So you can pause the video for a moment to copy this diagram. And then once you have it copied, I want you guys to notice that we have two angles, one here and one here. We got two lines that are intersecting. It looks like a scissor, doesn't it? And you might have seen these angles before. So if you know what if you know about these angle properties, you might go ahead and try solving for the x variable using this geometric relationship. Those of you who are not familiar yet, hopefully remember after this, these are called vertical angles. Now, vertical angles, it says they are congruent angles created by a pair of intersecting lines. So two lines that are crossing, looking like a pair of scissors, and then the angles that are opposite to each other, those are called vertical angles, and they are always congruent. So here's an example. Those of you who want to take notes on your separate paper, you do want to know this for tomorrow. Pair of scissors, two lines crossing. These two are vertical angles, and these two are also vertical angles, right? Even something that looks like this. These two are vertical angles, they're congruent. And these two over here at the top are also congruent. They're all vertical angles, okay? So then if they are vertical angles and vertical angles are always equal to each other, what we can do is set these angles equal to each other and write an equation. Okay, and then pause the video for a moment to see if you can solve this equation. And then if you have found the answer, coming back to check it, subtracting x both sides, I have 16 is equal to 3x minus 5. And then we're going to add 5 both sides. 21 is equal to 3x. Then divided by 3, you have x equal to 7. Now we're not going to be done here because we are actually going to check our answers. We're going to check to see if these two angles are actually congruent. So we're going to plug in the 7 right here. 7 plus 16 is 23. So it looks like this angle is 23 degrees. And if our answer was correct, that should also be 23 degrees. So that's going to be 4 times 7 minus 5. And that's 28 minus 5. So yes, this is also 23 degrees. Therefore, my answer is correct. Okay. If there's anything that you weren't sure of, or you want to go back to watch it again, then feel free to do so. You can always go back to parts of the video and watch it again to help you understand better. And the next one that I'm going to show you, I think you might know this pretty well as well. This one. I got a straight line, okay? The line through, so I got two separate angles. Two angles put together on a straight linear line. What kind of angles are these ones? Those of you who guessed it correct, kudos to you. These are called supplementary angles. Okay, supplementary angles are those that add together and they create 180 degrees. Okay, and it's usually straight lines. Straight lines are 180 degrees, always. Angle in a straight line is always 180 degrees. So then if you have a straight line, and another line that cuts it in two parts, then these two angles will add up to 180. So for example, this could be 100 degrees and this could be 80 degrees, supplementary angles. Yes, if those of you who are wondering about the triangle, all angles of a triangle, they add up to 180. So angles of triangles are also supplementary, right? So then in this case, on a straight line, we know that these angles, by definition of supplementary angles, these two have to add up to 180 degrees. So then we can write our equation as 2x plus 3 plus, I'm going to put parentheses around it because that's the first angle. And then the second angle is x minus 6. They add up to 180. Yes, you should put parentheses. You should put parentheses. Okay, so then if we add this together, we can get rid of the parenthesis now once we distribute pi positive. 2x plus 3 plus x minus 6. 3x minus 3 is 180. So 3x is going to be 183. And then you're going to have to divide both sides by 3. Therefore, looks like x is equal to 61. But we should check it. We should definitely check it. So you can pause the video and go ahead and plug in the 61 into your expression, 61 into the x, 61 into the x over here. If you do that, 2 times 61 plus 3, that's 122 plus 3. So the angle measured looks like on the left side is going to be 125 degrees. Okay, and then this one, it's going to be 61 minus 6, which is 55 degrees. And yeah, 125 plus 55 is 180 degrees. It works. So the answer was correct. Okay, supplementary angles. All right, so I got one more review coming your way. So you might see it already here. I'm going to read the 75 and see what I'm going to be talking about in this one. It says, Giselle started to prove that the triangles at right, or the bottom, sorry, are congruent. He was only told that point E is the midpoint of both segment AC and BD. He's trying to prove that the triangles AEB, we can call it, and then the other triangle, he's trying to prove that the triangles are congruent. And the only information that he knows is that this point E is the midpoint of the segment AC and BD. So we're going to talk about midpoint now. We're going to talk about midpoint. First thing I want to ask you to do is pause the video and copy both the diagram as well as a flow chart. Those of you who don't have the handout, if you do have the handout, you should still also copy the flow chart. So copy the template, okay, and then come back to the video. Okay, hopefully you paused the video, copied it, came back. Okay, so I'm guessing this is still a review. You should have seen the word midpoint. The definition of it actually follows the word itself. So first, some notes that you can copy maybe on a side. We're going to come back to this word again, so I hope you understand it. Midpoint. We're going to talk about midpoint again next week. It's a point that divides a segment into two equal parts. Divides it right in the middle. So this is segment AB. We got a segment AB, which you write it as a bar with on top of AB. If I put a point in the middle, assume that this is the middle, this is going to be the midpoint. I'm going to assume that this is exactly in the middle, and that's my midpoint. If that happens, then this part of the line segment, which I'm going to call segment AM, and then the segment MB or BM, whatever you want to call it, are going to be congruent because it's cut in half, right? They're equal parts. That's what a midpoint does. It cuts it into two equal parts. So then coming back to our proof here. This is the given information. The problem is telling us that E is a midpoint of the line segment AC and E is a midpoint of the line segment BD. So if you look at the flow chart, that's what it starts with. It's given to us that E is a midpoint of segment BD and E is a midpoint of segment AC. Okay, it's given in the problem. And then let's go down here. If E is a midpoint of the segment AC, by the definition of midpoint, now this midpoint is cutting this into two equal parts. Therefore, we now know that AE is congruent to CE. And you can say EC. Again, EC is fine, but that's the definition of midpoint. Okay, we know that this part and this part are congruent to each other because E is a midpoint. So that we can apply the same thing to the other segment. If E is a midpoint of BD, now we know that this part and this part are going to be equal length. So we can say that segment BE is congruent to DE, and that's also the definition of midpoint. Okay. Now there's another part about this triangle that allows us to come up with another fact. I think some of you might have figured it out already. Do you guys see a pair of scissors? I do. I got this line and this line crossing together. Therefore, this angle right here and this angle, those are vertical angles. And vertical angles are always congruent, right? So we could say this angle is congruent to this angle, and we can put that into this third bubble. Now be careful. Again, we got two angles named after just one letter. So we're going to have to name them separately. Name them separately. So I'm going to call this angle AEB. Then what's the other angle? If I start with A and then go to E, that's one tick mark. So then in the other triangle, I should start with C. A corresponds to C. And it's going to be CED. Angle CED. Okay, and how do I know that? Vertical angles. Vertical angles are congruent. We're going to say vertical angles they're always congruent. So do we have enough information to prove that they are congruent? Yes. The triangles are congruent by side, angle, side. So we're going to write it into the last bubble. Triangle AEB is congruent to CED triangle by side, angle, side. And there is our flowchart. Okay, so if you're getting tired already, you can feel free to pause the video and come back to it. But now we're going to practice flowchart with this. We're going to practice another proof with midpoint. Okay, something may be related to this. All right, so then the next one, I'm going to have you copy this one information. This one is a little bit different because it's now giving you information in words. So you might see a flow chart like this later next week. Also, this is usually the ones that we see in integrated 2. Okay, nothing different. Copy it down. And if you have, pause the video and finish copying it. Let's work through it together. So in this picture, we have tick marks. So we know that these two sides are congruent, okay? That's given by the tick marks. But there's another information given in words. So this word, it's actually repeating the tick marks that AB is congruent to BC, which we can see from the picture. And they're telling us that D, the point D, is a midpoint of the line segment AC. So planning ahead, let's plan ahead. With this given information, do we know that the triangles are congruent? The answer is going to be yes. So let's put some markings on it. We know that AB is congruent to BC. That's given to us. And D is a midpoint of the line segment AC. Therefore, this part and this part are equal lengths. So they're congruent. That's the second fact we can come up with. What else do we know about this triangle? Are they sharing something? Yes, they're two triangles put together, touching that middle line, which is BD. Okay, so this is congruent by side, 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 and we're going to put this together in a flow chart. Feel free to pause a video and do this on your own first, and then come back to check. That's totally fine. So those of you who are working along with me, always start with the given information. So the first thing is AB is congruent to BC. They gave that to us. So given, always start with given information. What else was given? They told us that point D is the midpoint of AC. That was also given. Okay. Now, even though that was given, that is not enough to say that those two are congruent. So we have to actually make a separate bubble from the midpoint information, right? Because it's a midpoint, what do we know? We know that the segment AD is congruent to CD by definition of midpoint. Okay, with the given information, we came up with another fact. Okay, and then we're going to leave that alone because that was another information about triangle that we already know. We found congruent parts by the tick marks. We found congruent parts by the definition of a midpoint. Okay, and then the last one, hopefully your favorite, reflexive property. Side BD is congruent to BD by reflexive property. They share it. So then what are the three information that allows us to prove the triangles are congruent? These congruent parts, the congruent side at the bottom, and then the shared side. All three informations lead to another conclusion that the triangles are congruent. And then here, don't even guess. So those of you who worked ahead, what I need you to know is this part should be exact same as what you are trying to prove. So if you look at the problem at the very top, it says prove that the triangle ABD is congruent to CBD. That's what it goes in there. They're telling you exactly what needs to be in your last bubble. And ABD is congruent to CBD by side, side, side. Okay. So that's going to be it. That is the end of the video. I'm going to pause it there. Feel free to go back to watch it. We're going to skip this part. Hopefully we'll have some time to go over this again next week, but this is where I'm going to end. And you should look forward to see another video with triangle congruent worksheet flowcharts. Okay?